Okay, in this video, we're going to actually apply our translation rules and start graphing some of these shifted functions. So in the first example, this graph is given to us, which is f of x, and there are two additional graphs we're going to draw on the same grid. The first one we'll draw in red. I want to graph f of x plus 1. So that means if you look back up at your rules, when you take a function and you add some number to it, that means it's going to be a vertical shift up that many units. So that means I want to take my entire function of f of x and move everything up 1 unit. So I'm going to look at all my points on here, and I'm going to just move everything up 1 point. So I'm going to move this point up 1. I'm just going to move everything up 1 point, and then when I reconnect those, that will be my graph of f of x plus 1. Now let's do the second graph in blue. The second graph says I'm going to take my entire function f of x and subtract 2. So when I subtract a constant value from my function, that means I'm moving it down that many units. So I'm going to look at my function f of x in black, and I want to move everything down 2 units, so that I'm going to take all my points and shift them down 2. So take all my points and just move them down 2. This will be my function, f of x minus 2. So notice on both of these, I'm adding or subtracting something to the entire function. So that's a vertical shift. And then depending on if it's positive or minus, we're going to be moving it up or down. Okay, next example. We have our function f of x, and we'll do this one in red. We have to graph 2 additional graphs on the same grid, and we'll do this one in blue. Okay, for the first one, we're taking 4 and we're adding it to the value of x. We're not adding 4 to the entire function, just to the value of x. So that means there's going to be a horizontal shift. Now, if we look back up at your rules, when I add something to x, that's actually going to be a shift to the left. So this means when I graph f of x plus 4, I'm just moving everything to the left 4 units. So I'm going to just count over 4. 1, 2, 3, 4. So I have this point here. 1, 2, 3, 4. Here's another point. 1, 2, 3, 4. 1, 2, 3, 4. And right here. So then when I connect it, that gives me my graph of f of x plus 4 in red. Now for the blue, notice I have 2 different translations here. I have f of x minus 1, and then I subtract 3. That minus 3 is subtracted from the entire function. So this is going to represent a vertical shift. I'm going to abbreviate as VS, a vertical shift down 3. When I subtract something from my x, that's going to be a horizontal shift. And because it's a minus 1, if I look back up at my rules, a minus something means I'm going to add it to the right that many units. So this is going to represent a horizontal shift. I'll abbreviate HS. And this is going to be to the right 1 unit. Now, when you have multiple translations, like we do in this one, we have 2 different translations, you want to make sure you do them in the correct order. Now, sometimes it doesn't matter, but a lot of times it does. So what you want to do when you have multiple translations, you want to think about it like as if it was order of operations. If I were to plug something in for that x, I would first subtract 1, and then I would subtract 3 because you do inside the parentheses first. So you want to do your horizontal shift first and then the vertical shift. So I'm going to take all my x's and I'm going to move them to the right. So I'm going to take all those points on f of x on my black function, and I'm going to move them all over to the right one, and then I'm going to move it down 3. So when I look at this point right here, I'm going to move it over 1 and down 3. I'm going to move it over 1 and down 3 for each of those points. So here is my new function, f of x minus 1 minus 3. I moved all those points to the right one and then down 3. Example 3, again we have 2 graphs. We're going to do this one in red and we'll do this one in blue. So for the first example in red, we have 3 times f of x. If we go back and look at our rules, if we multiply something by the whole entire function, that's going to be a vertical stretch or shrink. And then we decide if it's a stretch or a shrink by looking at what the number actually is. If it's greater than 1, it's a stretch. If it's less than 1, it's going to be a shrink. So in this case, we have a vertical stretch, which means lengthwise, vertically, everything is going to be tripled. All the lengths are going to be tripled. So if I look at this point right here, this is the point -5, 1. So instead of coming out to 1 on my y-axis, I'm going to multiply by 3. It's going to get stretched out by 3 vertically. So now instead of having the point -5, 1, I'm going to have the point -5, 3. This point here is the point -4, 3. Now, instead of having the come out to 3 on the y-axis, now it's going to come out to 9. I'm going to triple it. So this is what we have so far. Now for this point here, it's at 0, and when I take 3 times 0, I still get 0, so that one stays there. And then for this point here, I have the point 1, 2. My y value is 2, but I want to triple it, so now it's going to come out to 6. So it's going to come up here. So this is my new function, 3f of x. Everything gets stretched out vertically. Okay, now let's graph 1/2 f x minus 5. This is a vertical stretch or shrink because I'm taking the number and multiplying it by the entire function. So I have 1/2 times the entire function. Because it's less than 1, this is going to be a shrink. So I'm going to cut all my distances in half. But we also have this here. This tells me I have a horizontal shift because it's getting applied to the x. I have an x minus 5. It's not, that minus 5 isn't being applied to the entire function, just to the x. So it's a horizontal shift, and the minus tells me it's to the right 5 units. And then this 1/2 tells me it's a vertical shrink by 1/2. I'm going to cut everything in half. So the first thing I'm going to do is move everything right, and then I'm going to cut my vertical distance in half. So if I look at this first point right here, I have the point -5, 1. First, I'm going to move it to the right 5 places. So I have 1, 2, 3, 4, 5. And then I'm going to cut it in half. So my height right here, my vertical height is 1. So I'm going to go to, my point's going to be at 1/2. Then I look at this point right here. This is the point -4, 3. I'm going to move everything over 5. 1, 2, 3, 4, 5. And then I'm going to cut my height in half. So instead of being at 3, I'm going to be at 1.5. This point right here, I'm moving over 5. 1, 2, 3, 4, 5. And if I'm at a height of 0 and I cut that in half, it's still 0. And then this last point here, I'm moving over 5. 1, 2, 3, 4, 5. And then I cut my height in half. So that will be right here. So this will be my new function right here. 1/2 f of x minus 5. Let me erase some of this extra stuff so you can see it a little bit better. Okay, so we're going to start off with the function f and then 2x. When we multiply a value by x, that means it's going to be a horizontal, shrink, or stretch. If it's greater than 1, that means it's going to be a horizontal shrink. So that means I'm going to shrink all my horizontal distances by 2. I'm going to cut everything in half. So if I look at this first point right here, I have the point -4, +2. I want to cut this horizontal distance in half. So my new point is going to be at -2, +2. So let me erase the rest of this so it doesn't get cluttered. This point right here is at -1. I want to cut that distance in half horizontally, so my new point is going to be half of that at -1/2. This point right here, if I take 0 and cut it in half, it's still 0, so that point stays there. And then this last point, it's at 3 for x, so I want to cut it horizontally in half, which means I want it to now be at 1.5. So here is my final graph. It's squished in there because we cut it in half. But this is my graph of f of 2x. Okay, now f of 1/3 x, when you multiply a number times x, that's going to be a horizontal stretch or shrink. When the number that you're multiplying by x is less than 1, that's actually going to be a horizontal stretch. So everything is going to get stretched out by a factor of 3. So all the horizontal distances are going to triple now. So if I start with this first point right here, I'm at -4, and if I triple it, it's going to go out to -12, which is off the grid. So let's just put it over here somewhere. Okay, this point right here is at -1. When I triple that, it's going to come out to -3. When I try to triple 0, it's still 0. And then if I triple 3, that's going to come out to 9. So now, here's my finished product. It's stretched horizontally. It's pulled out. Think of the x-axis like an elastic and you're pulling it out. So this is my f of 1/3 x. Okay, last example for graphical examples. We're going to use our function f of x, and we're going to now practice reflections. When you take x and you multiply it by -1, that's this one here, that's going to be a reflection across the y-axis. Because you're switching all the signs of your x value. For this one here, this is going to be a reflection across the x-axis because you're switching all your y values. When you switch all the signs of your y values, then it gets flipped across the x-axis. But then we also have this here. When you add something to the outside of your function, to the entire function, not inside with the x, that means we're going to move it up 1 unit. So in that second function, when we graph the blue function, we actually have 2 things to do. The red function, we're just going to do a reflection across the y-axis. So all my signs for x are going to get switched. So my sign for x here is -6. So that becomes a +6 over here. For 0, it's just 0. right? When I switch the sign for 0, it's still 0. And then let's use this point right here also. If I take the x value for -3 and I switch that sign, that now becomes a +3. So that becomes +3, -3 down here. So this right here is my f of -x function. I just did a flip right over the y-axis. It looks like the y-axis is a mirror and it did a reflection. Okay, now we have the blue function to graph. We have two things to do for that. Remember, when you have more than one translation, you want to think about it in terms of order of operations to make sure you do it in the right order. So I would do the negative in front of the f of x first, and then I would add the 1. So we're going to do the reflection first. So when I look back at my original function, f of x, which is in black, I'm going to switch all the signs of my y value. So for this point right here, I have the point -6, 0. 0 is my y value. And when I switch the sign to 0, it's still 0. And the same thing goes for this. So those 2 points are not going to change. However, when I look at this point right here, I have the point -3, -3. If I switch the sign of my y value, it becomes positive. So this point now becomes up here, -3, +3, because I switched that sign. But then we also have to add 1 to all of these points. So we did the reflection, but now we have to move everything up 1. So this point gets moved up 1, this point gets moved up 1, and this point gets moved up 1. So we can erase those points, move them all up 1, and this is our final product. We flipped it over the x-axis and then we bumped it up 1. So that's this function here.